everyone. Welcome to our examples for 6.1. So 6.1 really, I hope, isn't anything super new. In your Calculus 1 class, you should have had a discussion about that the first derivative gives us velocity and the second derivative gives us acceleration given a position function. And so now we're just going backwards. So you read through the section. You don't need to worry about, there was part of it you didn't need to, I don't remember what page it was on, but we only have 8 weeks to get through this stuff. So I just wanted you to focus on the velocity and acceleration kind of angle of this section. So I'm going to do 2 examples for you and then call it good. So look at the examples in the book also, and make sure you ask me any questions if you have any over those. So let's look at our first example here. I already got it on the page. We have a particle is moving along a line, and then the velocity of that particle is given by this function, t squared minus t minus 6 over the interval 0 to 4. So we're only considering the velocity of this particle from t equals 0 to t equals 4. And whatever our units are in this, I don't know. I'm a pure mathematician. I don't really care about units very much. I mean, I care. Don't let any of your physics teachers or anyone else hear me say that. But let's look at this first. So we have a couple things we want to figure out given that we know the velocity, right, is t squared minus t over 6, and we're over the interval 0 to 4. So the first thing that we're going to look at is determine when the motion is in the positive direction and when it is negative. So we'll start off here with where is it positive and where is it negative? Well, I know I'm going to have a positive direction when my velocity is positive, and I know I'm going to have a negative direction when my velocity is negative. Another way to think about that is if I'm moving like forward or backward, or if we consider maybe like throwing a ball in the air, that's still along a line. So we could talk about maybe upward being positive and negative being downward, but it kind of depends on how you define it, right? Whether forward is positive and backward is negative. All we're going to talk about is where it's in the positive direction, where it's negative. So basically what I want to figure out is I want to figure out where is my velocity negative and where is my velocity positive. So one way of doing that is by determining where my velocity is actually 0 and then figuring out if it's positive or negative beyond where that's 0. So the first thing you're going to do is you're going to take your velocity function and I'm going to set it equal to 0, because I know that the only way for my velocity to change from being positive to negative or negative to positive is to go through 0. Think of that on the number line. If you want to go from positive to negative or negative to positive, you have to go through 0. So here's the hardest part of this problem, and that is the algebra. It's always the algebra that is the hardest part. I'm going to set that equal to 0, and we're going to see that my velocity is equal to 0 when v is 3, when my time is 3 seconds or minutes or whatever, and when my time is negative 2. Clearly the negative 2 doesn't really make sense for us. I don't know, unless you've figured out how to go backwards in time. You just let me know, write me a little email, and we'll go publish a paper. All right, so we have when at time equals 3, okay, I know that my velocity is going to be 0. That means, so what I like to do when I determine the positive and negative direction is I kind of just make myself a little number line. If you had me for Calc 1, this is also how we would, this is not to scale, obviously. I hope you see that. Clearly 3 is not between 0 and 4. This is kind of how I like to do the first derivative tests also. So I'm not going to worry about negative 2. I'm going to look at 3, and I'm going to determine what's happening to my velocity between 0 and 3 and 3 and 4. So I'm going to just pick a number in between 1 and 3, or 0 and 3. Let's just pick 1. And if I put 1 into this into my velocity function, I get 1 minus 1, which is 0, minus 6, which is negative. So I have a negative direction here. Right? And if we thought of this as like moving backwards or coming down, that means that I'm going down and then maybe coming back up, or I'm going backwards and then I'll go forward, probably. If I put in 3.5, so I'm going to look at this a little bit differently. If I put in 3.5, right, I'm going to get a positive for this part of the velocity, and 3.5 with 2 is also positive. So what's a positive times a positive? That is a positive, keeping it positive, keeping it greater than 0. So here we see we have a positive direction. So what do we know? We know we have a positive direction, right? From what interval? 3 to 4. I'm going to put open parentheses on those, because technically at 3, I'm neither positive nor negative, right? Because my velocity actually is 0. Where are we negative? From 0 to 3. Okay, so let me show you a little bit. Let me show you a graph of that. I'll show you that that actually does support, the graph supports what we have found. So if I plug in my function, I'm going to have to use x's. I guess I don't have to, but I'm going to. X squared minus x minus 6. So if I look at this, and let's look at x equals 4. And where else am I at? X equals 0. Decimals is the best. So if you don't have a graphing calculator, that's not going to be a huge problem. A lot of a scientific calculator will suffice. There will be some parts of your exam where you can't have a graphing calculator, so you'll probably want to look for a scientific calculator. But if we look at this, notice my velocity is negative, right? My function values are below the x-axis between 0 and 3, and then at 3 to 4 it goes positive. So that looks, you know, my calculus or my algebra really supports what is happening with the function. So we're done with that one. That was pretty good. Okay, so that was part A. That was pretty painless, I think. Part B is asking us to find the displacement of the particles. So as you saw in the section, displacement is just going to be where you ended the position, right? Where your particle is at, what would it be, 4, and then where your particle is at 0, and subtracting them. And so we found that our displacement was given by, and this was pretty easy to do, maybe not easy, but our displacement was given by the definite integral from a to b of my velocity, right? So in this case, I'm going from 0 to 4. My function is t squared minus t minus 6 dt. Take the antiderivative, I get 1/3 t cubed minus 1/2 t squared minus 6t, and we'll evaluate that from 0 to 4. When I plug in 0, everything's going away. When I plug in 4, I get what? 64/3 minus 16/2 minus 24, which gives us, it looks like a negative 32/3. And that's going to be in feet or meters or inches or whatever our variables, miles, are going to be, or about. So that's my exact answer. You know, I could also, well, I could stay exact. This is a negative 10.6 repeating, or if I wanted to do maybe a approximation, maybe like 10.67. Can displacement be negative? Absolutely. It just depends on your initial position of the particle, right? And then where you end up. So maybe, you know, if you're at a position in your particle and you move to the right a little bit, but then you turn around and you go to the left, then where you ended is smaller than where you started, right? Assuming that right is the positive direction. Absolutely, my displacement can be negative. It just really tells us about how far you are from where you started. Okay, so that makes sense. Now, part C though, which is find the distance the particle traveled, that can't be negative because we're talking about just a distance, okay, and not in relation to where I started or anything. I just want to know the distance. So remember, the distance, right, was a to b of the absolute value of v of t dt. So what we're going to have to do with this is we're going to have to break this up into two separate integrals. So what I want to look at, right, so remember absolute value, if you guys remember absolute value at all, like the absolute value of, let's say, some number x is just going to be x as long as x is greater than 0, and it's going to be the opposite of x if x is less than 0. And we could put an or equal to on one of these. So I mean, if you think about that, that makes sense. You know, if x is -3, then I just take the opposite of -3 and I get 3 out, right? If I have just 3, then I just get out 3. This is a really useful definition to know if you have, you know, big mathematical plans to continue on, which I hope you do. That's a good definition to know of absolute values. So we're going to break up v here. Now we already kind of know how v should be broken up, right? Whoa, sorry about that. No, stop. Close window. Oh, man. So look at v. What do I know? I know that it's negative from 0 to 3. We already saw that before in part A, and then it's positive from 3 to 4. So what I'm going to do then to take, apparently I'm going to use pink, which I don't hate, but I'm actually not going to do that. So the absolute value of v of t in this case, because I have this definition of absolute values, from 0 to 3, I'm going to take the opposite of the velocity, okay, plus, and then from 3 to 4, I don't need to take the opposite. I'll just do the velocity itself, right? Oh, I forgot a dt. How embarrassing. There we go. There's my dt. All right, so what do we get here? I get a negative 1/3. We've kind of already seen this t cubed plus now 1/2 t squared plus 6t, all from 0 to 3, plus, same thing here, just opposite signs, minus 1/2 t squared minus 6t. You can't do these together, guys. You can't do this as one integral. You have to do these as two separate integrals, and I expect to see that. Okay, so when we plug this all in, we'll get a negative 9 plus 9/2 plus 18. When I plug in 0, everything goes away, so then this plus sign becomes here. Then plus 64/3 minus 16/2. I don't know why I'm not putting that out. I should. Minus 24. Minus, and then put parentheses here. That's quite important because I'm putting in that 3. When I put in that 3, I get 9 minus 9/2 minus 18. Oh, that was not what I wanted to happen there. All right, and if we figure that all out with our calculator, we get 16.3 repeating. Or if we want to do that as a fraction, we get 49/3. If you want to know how to get the fraction on your calculator, just let me know. Feet, meters, whatever. I don't stand by that answer totally because sometimes I make mistakes when I'm doing arithmetic by myself. It's really bad if I'm doing arithmetic by myself. So, all right, I hope that makes sense. Let's see what else we're supposed to do. I think the last one here, right? Find the position function of the particle if s of 0 equals 3. So I want to talk about this just a little bit. So in your book, they give you a really interesting theorem that you should have written down where, you know, we can find s of t, and they do a good job of explaining this. I think it's kind of interesting because it's fun to come back and use the fundamental theorem. But I really want you to understand too that we don't have to use, oh, those can't be t's, we need to, sorry, use a different variable here. You are welcome to use this theorem, or if you want to, you could just figure this out yourself. So is this d? I think it's d, right? Yeah. So what do we know, right? We know that v of t is t squared minus t minus 6, and we know that the initial position of this particle was 3. Oh, sorry. I should figure that out before I get going on this. Oh my goodness. So sorry. I'm not meant to like be a YouTube star or anything, clearly. S is 3. So at time equals 0, the position starts at 3 and it's positive. So that would be, you know, 3 to the right of wherever our origin is or something. So, so you could use this. You could use this. Feel free to use it. But what I actually would do is just something that you probably did in Calc 1. I know that s of t, right, is the derivative, or excuse me, I know that v is the derivative of s of t. So what is s of t going to be? It's going to be the antiderivative of t with a constant in there that I have to deal with. So what do I know about s of t? It's going to be 1/3. We've seen this about 100 times now. Not true. Not 100. I shouldn't just throw out numbers if they don't mean anything. But the big thing here is that we have to consider this c, right? We have this constant when we take an indefinite integral. So up here we were taking definite integrals, so we didn't have to really, sorry, up here we were taking definite integrals, so I didn't have to worry about that c. But now I do have to worry about that c. And how do I find that c? Well, I use that initial condition, okay? So what do I know? I know s of 0, which in this case would be 1/3 times 0 cubed minus 1/2 times 0 squared minus 6 times 0, all plus c, right, must equal 3. Clearly all of that is 0, so if I solve for c, c is equal to 3. So what's my final answer? This is not your final answer, people. Your final answer asks for a position function, so your final answer best be a position function. or guess what? I'll take off. I know I'm so sorry. People think I'm nice, and then they have me for like calculus and realize how incredibly picky I am about these things. So there's my final answer. That is my position function. So if I ask you, like what is the position of the particle at 2 seconds, you could put the 2 in and there's your position. Well, if I ask you what is the velocity of my particle at 2 seconds, then we would plug it back into our velocity equation. I hope that makes sense. All right, let's do one more example that involves acceleration, and then that's about it. Okay, here's our last example. So we have a projectile is launched vertically upward from ground level with an initial velocity of 60 meters per second. So we're going to assume that only the force of gravity acts on this projectile, and it produces a constant acceleration of 9.8 meters per second squared. If you're an engineering major, which I'm assuming a lot of you are, some probably computer science. But if you're an engineering major, this should look familiar to you. You've probably taken physics and talked about acceleration due to gravity. 9.8 meters per second squared, or I believe it's 32 feet per second squared if we're in feet. All right, so determine the position function of the projectile. So again, you had a theorem that you could use from the book, theorem 6.2, on page 408. You're welcome to use that theorem. Sometimes it's okay to just think about it too, and to just use antiderivatives. So what do we know, right? We aren't given a whole lot. Let's kind of see what we know. We know it's vertically upward from the ground level. So what does that tell us? Ground level tells me that my initial position, right, must be 0, right? So if I have a projectile that's going to shoot up, we know that this is going to be my initial position, and that's going to be at 0. What else do we know? We know that we have an initial velocity of 60 meters per second. So that's pretty easy. That's v of 0 equals 60. And we'll go ahead and say that that's positive. So we have to decide what are we going to indicate to be positive and what is negative. So I'm going to say that going up is positive, and then when it comes back down, I'm going to say that's a negative direction. I know it's a bold stance to take, people saying that up is positive and down is negative. So I know that this is my initial position, right? This is my initial velocity. And then what else do I know? I know that I want to stay with the same colors because we should. We have a constant acceleration. So what is my acceleration function? My acceleration function actually is going to be just 9.8. But let's think about how I've defined the movement of this projectile. I've said that going up is positive and going down is negative. So if you think about gravity, right? Gravity is a force that causes things to come back to the earth. The earth doesn't want you to go, stay. So we're going to have to say that acceleration is in the negative direction, right? So you have negative 9.8. Now, I do care about units, I promise. Sometimes I pretend like I don't. I'm going to just tell you right now, I don't care about units while you're actually doing the calculus. You do need to use units, however, in your final answer, okay? And I get that some of you have a physics teacher that is forcing you to use, gives you the opportunity to use units throughout your whole work. Please, if you want to do that, please do, okay? So whatever you're comfortable with, but what I require are units at the very end. So how am I going to find my velocity? Well, remember, we know that velocity, and they didn't put this in your definition list. You might add this to your definitions that you wrote down in 404. So, but what do we know? I know that my acceleration, right, is the derivative of my velocity. It's how quickly your velocity is changing. So how am I going to find my velocity? Well, I'm just going to integrate, right, that constant acceleration, negative 9.8 dt. So what would this be? This would be negative 9.8 t, but then plus some constant c, right? So how do I find that constant c? Well, I know my initial velocity. I know that v of 0, which would be negative 9.8 times 0. Be careful there. In this example, I guess all the examples I've done so far, this kind of just goes to 0, but please be careful with that, because I think there's an example on the fun sheet, and there is some in your suggested homework that involves like cosine or sine, and so it doesn't always go to 0. Be careful. So with that c being 60,
I can learn to understand you much better if...
Oh, I'm so sorry. So sorry about that. This message brought to you apparently by Microsoft Surface. I love my Surface for recording these lectures, but I'm actually kind of a Mac girl, so I only use the Surface for the lectures and grading homework, and that's it. All right, V of t, then this is great. I have a function for my velocity. Now, I guess I should have said this. Why am I going to velocity? Because if I can go to velocity, right, if I can find my velocity equation, well, I know my velocity is the derivative of my position function, which will let me get to my position function. So I know S of t then is going to be the integral of a negative 9.8t plus 60 dt, realizing I'm going to have to bring in that constant. So this probably looks familiar to you, negative 4.9 t squared plus what, 60t plus c. So you may have seen this in like a physics class or something. Again, if we do s of 0, sure enough, all the zeros cancel out. And because we had an initial height of 0, that means my c is 0. So what's my final answer, you guys? Finally, s of t equals a negative 4.9 t squared plus 60 t. And we're done. Look at that. That's great. Okay. Pretty easy. Please make sure you go through all the examples in the book. Please make sure that you work on the fun sheet, right? The fun sheet will have solutions. Look at the solutions. In this, I try and show you how to write notation correctly in solutions. And then, of course, go over the suggested homework. If you want me to look over any of your work on the suggested homework, I'd be happy to do so, especially before you turn in your homework quiz. All right, you guys, go have fun.